Hey neighbors, welcome to chapter 0. I'll be honest with you, for a long time I wrote JavaScript by just poking it with a stick until it worked. If the code ran, I was happy, but as soon as I started building complex systems, I kept hitting walls. Magic bugs, weird behavior, it was just pure chaos. So I decided to stop guessing. I started looking for the absolute fundamentals, the stuff that stays true 10 or 15 years from now, no matter what library is trending today. I want to share the mental model I am building for myself. Once you get this, all the weird parts of JavaScript suddenly start making sense. You won't have to memorize definitions anymore. You will see exactly why hoisting happens, how closures actually work, and why async code behaves the way it does. We are going to stop guessing and start understanding the machine we are actually controlling. Let's dive in! Alright, let's go to draw our JS runtime mental model. JavaScript itself is text which does nothing on its own, but JS runtime has the real power. It does real things like manipulating DOM, fetching and sending data, and so on. So let's start with the engine. So this is our engine. Like V8. Engine itself is isolated, it is not able to make requests, it doesn't know what time it is, it doesn't know what user event is, and so on. What engine does is reading our JavaScript code line by line, and when it finds a variable declaration there, it prepares some space in memory. If it finds some function call, it puts this function to the call stack. So let's draw memory heap and call stack. So memory heap and call stack. So once again, data, our variables are stored in memory heap, and function calls are stacked in the call stack. In memory heap, we have also intrinsics. Intrinsics are sitting there from the beginning when the program is started. It is predefined JavaScript objects like math, array object, JavaScript object, and so on. And we have also garbage collector here. Garbage collector. And garbage collectors is analyzing memory heap, and if it finds data which are not reachable anymore, it deletes it. It is like memory optimization, and it prevents memory leaks. As I said, JavaScript engine is isolated, it is reading code, it is managing memory, call stack, but it can't send requests and do the real world things. For this, we have another part of JS runtime, and it is API. So APIs. For web browser, we have web APIs, and for Node.js we have Node APIs. The bridge between web APIs or not APIs is a global object. For web browser it is window object, and for Node it is global object. Window and global have its own properties like fetch API, local storage, set interval, and so on. So when engine needs to do something with window DOM update or something else, it calls this API, and the API does the thing. We have also another thing here, and it is queues, microtask queues and microtask queues. So let's draw a line. So here is micro task queue and task queue. What is it? In order to understand this queue, we need to go back to the call stack. When engine calls some web API, for example, synchronous API like local storage, for example, local storage get item, it is going to get this item from the local storage, and it returns back to the call stack. And this is synchronous, so call stack is paused for a while, blocked. It doesn't execute other function, and when the local storage.getItem returns value, it continues with its execution. But if it calls asynchronous API, for example, fetch API, call stack continues with execution. It goes to another function and it delegates this operation to web APIs. Web APIs is trying to get data from server. It is waiting for the server, and when we get response from the server, it is passing the callback function to the microtask queue, and this microtask queue is has higher priority than task queue, so it is like VIP line. And for example, if call stack calls set interval, for example, callback function is passed to the task queue. So there are two lines, one is with higher priority and second with lower priority. And here we have also event loop, and it constantly checks call stack, and if call stack is empty, if there are no functions running, it is going to check microtask queue and puts callback function to the call stack. When microtask queue is empty and call stack is empty, it looks to the task queue and it puts it to the call stack. And that is pretty much it. We can see that engine itself is single-threaded, but web APIs and Node APIs can run multiple threads parallelly, so it is multi-threaded part of JS runtime, and this sophisticated pattern allows us to run single-threaded language which mocks multi-threaded behavior. I hope you found this valuable for you, and in next video we are going to discuss about engine and execution context.